Hey, it's Ms. Hochstetter here making the metric conversions video that's long been waited for. This is the skill most students struggled with the most on our skills assessment, so I wanted to take some time to make sure I really made this very clear for you moving forward. So let's just start off with the basics. So we have the metric system. That's the system we're going to be using in science class and physics. It's the decimal measuring system based on like a meter or a liter or a gram. To use the units that we use in class. So those are the main ones that we use, the meter, liter, gram, but as you know in physics, there's a lot of different units. Later in the year, we'll get into units for things like electricity and energy, and that's going to be a different unit base, but the process of converting is still the same. So that's actually very nice, which the metric system is really good for. So let's talk about what a base unit is. So base unit is a fundamental unit that is defined arbitrarily and not by combinations of other units. So in the SI system, the scientific system, metric system, so gram, second, ampere, Kelvin, those are the base units. But we can also use this method to convert other quantities like newtons, joules, watts, or ohms. And don't worry if you don't know what a joule is yet, or a watt, or an ohm, because the process is still going to be the same. So let's look over here. This is the Physics Reference Table. This is on the bottom left corner of the first page of the Physics Reference Table. So you don't need to memorize any of these prefixes because you can just use this table to help you out with your conversions, which is awesome. Now, if you notice here, we have the prefix, we have the symbol, and we have the notation. But you'll notice not all of these notations go in order. The exponents change depending. That's because this reference table only includes the prefixes that we use the most in physics. So you probably notice we use kilo a lot, centi, sometimes we use milli at this point in the year. Later in the year, we'll be using micro and nano. Every now and then we'll use pico. It's not very often when we use giga or tera, but you will see them. But those are the ones we usually use the most. So that's the prefix for how you say it. The symbols are just letters. Oh, I'm on the eraser. There we go. So that's what these would look like. And that's the letter that goes in front of the base unit. Then finally, the notation is what the numerical value is for that. So we have like 10 to the 12th for tera, and so on. So when we want to convert, there's some steps that I want you to follow. So I'm starring that over here. So step number 1 is to convert the given unit to the base unit by replacing the prefix or symbol with the notation. So the base unit is actually not on this table, but if I were to put it, it would be right here. This is where the base unit is. The base unit is basically anything to 10 to the 0 power. But as you can see in the exponents, they don't go by every single exponent value. But this would be like where a meter goes, for instance, or where a liter would fall in the chart. It just doesn't include it. And that's okay, because we don't actually really need it to do this. I'll explain with an example in just a moment. So then when we convert to the base unit, we're going to convert that into the needed unit by dividing step number 1, whatever you get there, by the needed unit notation. So when I say the needed unit notation, what I mean is this column right here. All right, so let's do an example. So example number 1, it says convert 1,000 kilojoules to megajoules. So you might not know what the J means yet because we haven't taught energy, but J means joules, and it doesn't matter. Even if you get a unit you've never seen before, you can still do the conversion. So first step, we're going to take 10,000 kilo. We're going to look up the base unit notation. So kilo, there it is with the K. It is 10 to the 3rd. So we're just going to replace this K times 10 to the 3rd. And now it's just in joules. So that would be step 1. We've completed that. Then you're going to convert into the needed unit by dividing step 1 by the needed notation. So if we're going to mega joules, which is a capital M, so we look at our table, we see megas right here. We are going to divide what we got by 10 to the 6th. So this would be 10 to the 6th. So at this point you have a few options, you can just plug it into your calculator how that looks, or if you know how to solve this mathematically without the calculator, you can do that. So when I do this, I am going to do that divided by 10 to the 6th, and this equals 1 megajoule. So all of these cancel out, but I recommend just plugging it into the calculator if you don't want to mess around with exponents. So that's the answer for that example. Now let's do a really small example, but the steps are still the same. So we have 500 nanometers. So I'm going to switch the color to maybe red for this one. So we have 555 nano. So we're going to look at our table, and that's the symbol. We're going to replace that with 10 to the negative 9th, so times 10 to the negative 9th. And that's step 1. So now it's in meters. But we don't want it in meters, we want it in centimeters, so we're going to divide that by the needed unit. So the needed unit in this case is centi, so centi is right here. We're going to divide this by 10 to the negative 2. And then when you do that, you will get divided by 10 to the negative 2, 5.55 times 10 to the negative 5th centimeters. So that's the answer to that. Now, sometimes in the calculator, like my calculator wrote it out like this. This E means 10 to the exponent, and then this number would be the exponent. So when I wrote it over here, I wrote it in scientific notation, but this is what my calculator spit out. So that's just what that capital E means, just in case you didn't know. All right, so now let's go from 4 kilograms to milligrams. I'm going to switch colors again. So let's use purple for this one. So 4 kilograms, so 4 times kilo. Kilo, again, we already know is 10 to the 3rd. And then we did the first step, and then we're going to divide that by milli. So we look at milli, which is 10 to the negative 3rd, divided by 10 to the negative 3rd. So 4 times 10 to the 3rd, divided by 10 to the negative 3rd. Oh, it went wrong in my calculator. And it gives me a much larger number. And I'm just going to simplify this using exponents. When we have a negative exponent in the denominator, we can flip it up to the top, so it becomes 4 times 10 to the 3rd times 10 to the 3rd, which once you combine the exponents would become 4 times 10 to the 6th. Again, if you're like, I don't know about these exponents, it's freaking me out, you can just plug it into the calculator and do it that way as well. All right, so let's talk about the purple sheet. So this is question number 1 and number 2 on the online purple sheet quiz for practice on these skills. So we have 10 terabytes or terameters, which looks like this. And we're going to convert that into our base unit. So we have 10 times tera. So we look what tera is, and we see tera is 10 to the 12th. So we're going to replace the t with 10 to the 12th. So now I've converted it into my base unit, and I'm going to substitute dividing by what giga stands for. So if we look at our table again, we see giga is G, 10 to the 9th, divided by 10 to the 9th, and that's going to give me 10 times, 12 minus 9 is 3. So this is really like 10 to the 4th. So the answer would be, there we go, 10,000 gigameters. Now this one I really like because this is one we have in lab all the time, converting 100 grams to kilograms. So 100 grams, that's already in the base unit. So we can just skip step 1 and just go into the next part. So kilo, we look in our reference table, kilo is 10 to the 3rd, 10 to the 3rd, so we're going to take 100 divided by 10 to the 3rd, and that's basically moving the decimal over 3, and that would be 0.1 kilograms. and that would be how you do that. All right, so hopefully this helps clarify how to convert between units using the reference tables. Let me know if you have any questions by leaving a comment, or you can subscribe to the channel.